Hey guys, welcome back to JMC Maths channel. In this video, I'll be doing some multiple choice questions that will definitely help you for your next maths exam. Stay tuned. Guys, if you haven't checked out my other two videos in answering multiple choice questions, I recommend that you click the link above to check those videos out as well. This is part 3, guys. So let's have a look at question 1. So if P is equal to the elements 2, 3, 5, and 7, Q is equal to the elements 2, 3, and 6, and S is equal to the elements 2, 4, and 5, then P intersect Q intersect S is equal to. So we first need to understand what we mean by this symbol, guys. So it's the intersection symbol, and the intersection of sets, it has only the elements common to all the sets. So what we're really trying to do, guys, is to find all the elements that are common to P, Q, and S. Okay, so let's have a look at the elements in P, guys. Let's have a look at the elements in Q, guys, as well as the elements in S. If you look carefully, you'd realize that 2 is common to P, Q, and S, which therefore means 2 would have been the only element in that set. Okay, so it therefore means the intersection of P, Q, and S would have been 2, which therefore means our answer is A. Lovely. Let's now have a look at question 2, guys. What you can do is just pause the video, try this question, and when you finish, play the video to see if you got the same answer. So the set of x such that x is greater than or equal to 6 and x is less than 10, where x is an integer, is. So this, guys, is a set builder notation, and what we are required to do is just to list the elements that are described in this set builder notation. So you'd realize carefully that it says that x is greater than or equal to 6, which therefore means 6 will be included, and it also said that x is less than 10, which therefore means we will not include 10. So we're listing the elements. We start at 6, guys, and then at 7, 8, and 9. And remember, it's an integer, so it must be all numbers. So it therefore means our answer for this question is A. Lovely. I hope you got this one, guys. Let's have a look at question 3, guys. So if Q is equal to A, B, and C, how many subsets can be obtained from the set Q? So again, we first need to understand what we can do to work out the number of subsets. So let's have a quick recap. So a set with n elements has 2 to the n subsets, which really means that that n will just replace it with the number of elements in the set. So the number of elements in Q, that's equal to 3. And how did I get 3, guys? Remember, it's 1, 2, 3 elements. It's just A, B, and C, so that's 3 elements. And now we're asked to work out how many subsets can be obtained from set Q, which therefore means the number of subsets would have been equal to 2 cubed. And remember, all I did, where I have that n here, I would just simply replace it with the 3 because there are 3 elements, which therefore means our answer for this question is D, guys. Also, they didn't ask you to work out like the exact value, so that's fine. But if they ask you to do that, it therefore means you'd be multiplying 2 times 2 times 2, which therefore means you'd have gotten 8, guys. Let's now have a look at question 4, guys. So question 4 refers to the following information. M is equal to the elements P, Q, R. N is equal to the elements P and Q. Which of the following statements is true? So let's have a look at our first option. So the first option reads as M is a subset of N, and what that means is that all the elements in M would have been elements of N. So let's check. All the elements that are in M should also be in N. So that's P, Q, R. They should also be a part of N. you'd realize that R is not a part of N, so that cannot be true. B now, guys, M union N is equal to N. So let's list the elements of M union N, and then we can compare it to N. So the union, guys, is really just combining the two sets, and we don't need to repeat elements. So M union N, that's equal to P, Q, and R. All I did was to combine the elements in M and N without repeating. So now we're comparing these elements, P, Q, and R, and what B is saying is that they're also equal to N. If you check N, you'd realize it's just P and Q. So right away you can agree that no, they're not equal to each other. So B could not be your answer. Let's now have a look at C, guys. So C is M intersect N, which therefore means we're writing what's common to both M and N. So I write that M intersect N. All the elements that are common to M and N. So we can agree that must be P as well as Q. And what C is saying is that M intersect N is an empty set. And we can agree that that's not true, guys. Right? So it therefore means C cannot be your answer. Right away, it therefore means we only have one option. So D must be your answer. But let's just check to make sure that's true. So we know that M intersect N is equal to P and Q. And it says it must be equal to N. If we just look at the elements in N quickly, we'd also realize that it's P and Q, guys, which is exactly the same as M intersect N, which therefore means our answer is D, guys. Let's now have a look at question 5. So given that P is equal to 2, 3, 5, 6, that's in one set, and Q is equal to 2, 3, 4, then P union Q is described as. So we first need to understand what we mean by P union Q, guys. So the union of two sets, P and Q, is the set of elements which are in P or in Q or in both. So it's really having P and Q combined together without repeating any of its elements. So let's have a look at the elements that we have in P union Q. So P union Q is equal to 2, 3, 4, 5, 6. And that's it, guys, because all we did just now was to just combine the elements of P and Q by just listing them without repeating any. So it therefore means we're looking at the answer options to see which one of those set builder notation would have represented P union Q. We can agree that we start at 2 and we end at 6. So looking at A, if you realize A starts at 1 because it says X is greater than or equal to 1. So it starts at 1 and it ends at 6 because it says less than 7, and we know it's a natural number, so it can't be a decimal. But A is not our answer. Let's have a look at B now. So B, X is greater than 1, which therefore means would start at 2, and then it says X is less than 7, which means that we end at 6. So B looks like it could be your answer, but let's just check out C and D and then we can come back. So looking at C, we start at 2 because X is greater than or equal to 2, but we end at 5, guys, because it says X is less than 6. So therefore means C cannot work. We also agree that A couldn't work. And then let's have a look at D, guys. So X is greater than 2 this time around, so therefore means 2 is not included. And then it says X is less than 6, which therefore means 6 is not included. So therefore means D cannot be your answer. So answer is definitely B, guys. Let's now have a look at question 6. So in the Venn diagram, the shaded area represents. So look carefully at what's being unshaded, guys. Look at the unshaded region. I'm going to highlight it so you can see it. All of P is unshaded, but we're interested in the region that is shaded. So we can agree that the region that is shaded is not P. Okay? So if it's not P, it therefore means we can write it as P complement, and we use a little symbol here to represent the complement of a set. So therefore means our answer for this, guys, must be A. Let's now have a look at question 7. So if P is equal to factors of 6 and Q is equal to factors of 4, then the shaded region represents. So again, the shaded region would have been the intersection, guys, meaning what is common to both P and Q. So let's first list the factors of 6, which should have been set P, and then we'll list the factors of 4, which is set Q. So that's our first step. So factors of 6, 1, 2, 3, 6. And then the factors of 4, 1, 2, and 4. Remember what I said. The shaded region represents what's common to both P and Q. So what are the common factors that we can see? We can agree that we're seeing 1 being a common factor because it's being represented in factors of 6 as well as factors of 4. So I'll write 1, as well as 2 is common to both 6 as well as 4. So 2 is also a common factor of 6 and 4. And those are the only two, guys. So it therefore means our answer for this question is B. Lovely. Let's now have a look at question 8, guys. So in the Venn diagram, so we have our universal set is equal to students who play games, and then H represents students who play hockey, and V represents students who play volleyball. The number of students in each set is indicated. How many students do not play volleyball? So we want to figure out how many students do not play volleyball. So I'm just going to cover it. I'm not interested in it. What I need to find is how many students do not play volleyball. So clearly I'm seeing that there are 5 students who play hockey only. So that's 5. And there are 3 students who play neither sports, which therefore means that's 5 plus 3, and that's equal to 8, guys. So therefore means our answer for this question is D. Lovely. I hope you got this one, guys. Let's now have a look at question 9. So which of the following sets is equivalent to A, B, C, and D? So we first need to understand what we mean by equivalent set, guys. So equivalent sets, they have different elements, but they have the same number of elements, okay? So therefore means if we look at the number of elements that are in this set, that's 1, 2, 3, 4. So therefore means a set that is equivalent to this set must have exactly the same number of elements. So therefore means in our answer option, we are looking for a set that has exactly 4 elements. Looking at A, there's just 1 element, so nope, can't work. Looking at B, that's 1, 2, 3 elements, cannot work. Let's look at C, guys. So that's 1, 2, 3, 4. Ooh, that's it, guys. Definitely C is our answer, which therefore means I can just circle C. Finally, guys, let's look at our final question now. So if U equal to, we have these elements in our first set here, 1, 3, 5, 6, and 8, and A is equal to 3 and 6, then the number of elements in A complement is, again, remember A complement, guys, represent everything that's not a part of A but is a part of our universal set. Okay, so let's have a look at this now, guys. So we know that the elements that are a part of A would have been 3 as well as 6. We're not interested in those. What we're interested in is everything that's not A, because that represents A complement, okay? So it therefore means 1 would have been not A, right? 5 would have also been not A, as well as 8 would have been not A. They ask us for the number of elements in A complement, right? Which therefore means we're just counting the elements. And we can agree that's 1, 2, 3. So our answer for this question, guys, is definitely B. And that's it, guys. I hope you got this one. Thank you so much for watching this video, guys. Please don't forget to subscribe to my channel, hit that notification bell so that you're notified when I post new videos. Like and share this video. Thanks for watching, guys.